solve a square root, and he'll solve a rational exponent, like x to the 4/5 power. Those are all things that we did last year, and again, now we're like cramming it into a little review chapter. So at the bottom of page 15 is the quadratic formula problem. That will do a little review here. I promise I won't put anybody on the spot and make them sing. If you had Mr. Warnock, he sang to you. So nobody has to sing. There we go. So the quadratic formula, anybody remember it? Harris.
B plus minus square root with b squared minus 4ac divided by square.
Awesome. Why do we use the quadratic formula? Why was it created, Virginia? Yeah, when you can't factor. So if a problem is not factorable, and you still need to find an answer, the quadratic formula was created. The other way that you could solve it would be completing the square. That also was created to get around the not factoring problems. Now these answers aren't going to be nice answers because you're not factoring and getting whole numbers or nice fractions. You're going to have a square root since there's a square root in the problem. Just a little reminder, A, B, C. A is with x squared, B is with x, C is the number by itself. And then literally, it's a plug and chug. So you have a formula, you plug the numbers in, you break it down, pop out an answer. B would be -3, but -3 becomes a +3. So you're taking the opposite of B. And then you're just plugging in those numbers that represent A, B, and C. After you plug them in, then you simplify. So break down those numbers, simplify it. Brandon, you know what number goes underneath the square root?
I didn't get that far yet. I just on the page that we were on.
Oh. Since you haven't been in math class for a couple days, I guess. What number goes underneath the square root? Did you know? 41. Yeah. Can 41 be broken down? It's prime. So 3 plus or minus the square root of 41 over 4. Your answer looks messy. It's not a nice x equals 1 and x equals -3 halves, but that's because it's not factorable. This is at least exact. Any questions? So the other 3 equations we're going to look at then, just kind of build on the equations we've been working on. Number 4 just tells you to solve, so it doesn't really give you any directions as to how to solve it. So you have to think back in your memory bank, what could you do to solve something that looks like this? We have 3x to the 4th equals 48x squared. What do you think, Brandon?
Get them to one side.
Yeah, good idea. Let's get them to one side.
And then take out a GCF.
Perfect. Set it equal to 0. Anytime there's more than one x, you have 2 x terms. One has a 4th, the other one has a 2nd. Get them on the same side, see if you can factor them. And what'd you say to take out?
A GCF.
Which is?
The 3x squared.
Good. So GCF 3x squared. And 48 divided by 3. 16. This is still factorable because it's now a difference of perfect squares. So we can break that part down. GCF was 3x squared, and then the x plus 4 and the x minus 4. So 2 answers, positive and -4. And then this 3x squared, what does that mean x is equal to? Virginia? 0, yeah. Never divide by x. So Brandon said the correct thing by taking the 48 to the other side, getting them on the same side. You don't ever want to divide x out of the problem because then you're actually like taking an exponent away, you're eliminating a solution. And we wouldn't have that 0 there if we divided out the x. Questions? Alright, problem number 3 for the day, even though it says number 5. This one has radicals in it. So the square root of 2x plus 7 minus x equals 2. Libby, what do you think was all this?
So first you would get the x over to the other side.
So isolate the radical. If it were absolute value, we would isolate the absolute value. So whatever the symbol is, we're going to try and isolate it. And then what, Libby?
Then you would do square to cancel the square.
So to cancel the square root out, we'll square it. And on the other side, you're squaring that whole quantity. What does it mean if you're squaring the whole quantity?
That means it would be x plus 2 times x.
Right, nice job. So if you have a quantity that's squared, really that means there are 2 of them. You're multiplying the x plus 2 times the second x plus 2. So the goal of squaring the left was so that we just get 2x plus 7. The right side, foiling that, is x squared plus 4x plus 4.
Then you subtract 2x and then you subtract 7 to get x squared plus 2x minus 3 equals 0. And then you factor everything.
Nice job. So that factoring that a lot of you probably thought you did too much last year, every chapter I tried to throw in a factoring worksheet somewhere, was because it really is the basis of most of the math problems we'll work on, or a good number of the math problems. Even in trig, we'll factor trig terms. So we'll factor with sine, cosine, and tangent. So if you can factor now, the factoring in trig should be a little easier. Brandon, in the parentheses, what would the 2 factors be after you?
Negative 1 and positive 3.
Good. So x is positive 1 and negative 3. What are the directions of this one? I want you to do that the other one didn't say.
That's a solve and check.
Yeah, it's a solve and check. So just like having something in the denominator, having absolute value, anytime you manipulate a problem, you add extra things to the problem. We squared it. Now we have a larger power than what we started with. You need to check your solutions. So make sure you go back and check them into the problem. And it's just back to the original. So we have 2 times 1 plus 7 minus x, so minus 1 is equal to 2. Or plugging in the negative 3, 2 times negative 3 plus 7 minus the negative 3 equals 2. So you're taking your x, you're making sure it's a solution. The first one, we have the square root of 9 minus 1, which is equal to 2. Eric, does the square root of 9 minus 1 equal 2? Yeah, that one's good. The second one is the square root of 1 plus 3. Eris, does the square root of 1 plus 3 equal 2? Nope. Are you sure? Not even because it's Tuesday?
I don't know if I could choose that.
Tuesdays could be special, right? So, no, it doesn't equal. So, circle the 1, cross off the other. X is equal to 1. So, extraneous solution on negative 3, an extra answer that appeared from manipulating the problem. Any questions? All coming back to you. And we're only on day 6. Look at all that math we've done, and we're only on day 6. The last one on this page here, again, solve and check. We have rational exponents. So this time the fraction is part of the exponent. 4x to the 2/3 minus 8 equals 0. Just kind of think, like, what would you do when it looks like this?
Can't you just take a 4 out?
So she said, can't we just take a 4 out? Yes, you can take a 4 out. Chelsea, I'm going to even say even better than that would be what? Because there's only one x in the problem. How about take the other 8 to the other side and take out the 4? So let's get that 8 to the other side and actually divide the 4 out. 4 is just a number. You're allowed to divide by numbers. Get them out. Make the numbers smaller. But because it's just x and it's not like an x squared and x cubed and x to the 4th, this is a case where you can take a number to the other side. So now it says x to the 2/3 is equal to 2. So x is by itself, except it still has an exponent with it. Michael, do you remember what to do when there's a rational exponent?
Do you multiply by the reciprocal?
Nice. Did your sister tell you the answer because you talked to her between 7th and 9th period?
No, I wouldn't ask her for the answers.
Oh, yeah, she says you're pretty smart.
I am.
She gave you a nice compliment today.
Thank you.
Yeah.
She was
You'll have
actually hitting on me earlier.
Oh.
She claimed it was my fault for her hitting the mailbox. That's what she told Mr. Woffington.
Oh, I wouldn't doubt that. Why was she talking to me?
So to get rid of the 2/3 power, since it's a fraction, you multiply by the reciprocal. But you keep it as an exponent on the other side. So fractions cancel with the x, and now it's just x. Don't grab that calculator. I know you want to. Don't pull for that calculator. Because instead of using your calculator, how do you think you could rewrite 2 to the 3 halves?
Would you like move the 2 to like the 1?
Okay. You don't remember? Why did she call it? Anybody else remember? Virginia? So the denominator makes the root. So it's a square root. Technically there's a little 2 there, but when you say square root, it's in the name. And then it's 2, the power is the numerator, which is cubed. Because you put a square root in a problem that wasn't initially there, don't forget a plus and a minus. That's the common thing to forget. Anytime the square root goes into it because you're solving for something, the plus or minus goes with that. So 2 cubed becomes the square root of 8. And then what's the square root of 8? Chelsea?
2 times the square root of 2.
Yeah, 2 times the square root of 2. With a plus or minus of it. No calculator necessary, at least for that part. So rewrite the 2, make it the square root of 2 cubed, taking that exponent, rearranging the way it's written, and then break down the square root of 8. So it does say to check, and I rarely say this, but you might actually want to use a calculator to check it. You know, those words are coming out of my mouth. But if you check it, we have 4 and then 2 square roots of 2 to the 2/3 power. You want to make sure that equals 0. Same thing with the negative. 2 square root of 2 to the 2/3 power. After you subtract 8, that needs to be equal to 0. So just make sure that you do check. If it says to check, make sure you are checking those solutions. And do they work? They actually both work in this case. So both of them would be the solutions. Any questions with solving equations? Algebraically or graphically? Remember, you can always graph something in the calculator to check your work. So we solved, I don't know, probably 6 or 7 different equations over the last couple of days. So we're going to slightly switch gears, continue with solving, but we're going to switch from an equation to move to an inequality. Today we're just going to do a little review on solving basic inequalities, and we're going to talk about interval notation. Tomorrow and Thursday, we're going to look at solving inequalities that are not linear. So the only inequalities you have solved so far have been linear inequalities, which would be like these 2 that are up here. But we're going to solve quadratic inequalities. We'll also solve rational inequalities. We already did the absolute value inequalities. The next 2 or 3 days will be more new. So the problems that we'll be solving, the process, you may, like we have done some of the algebra, but the actual problems, solving a quadratic inequality isn't something you've done yet. So there will be a little bit of new material that we'll be actually covering the next couple of days. So before that, I figured today we could just kind of do these couple review problems. See if you can try letter A. So solve the inequality, graph it on a number line. Most inequalities have a graphed solution because it's not one answer. It's a range of values, which is why we kind of display it on a number line. So try A. See if you can solve that. And then we'll talk about B and also those solution or the interval notation at the bottom. We're going to hand out books later in the week as well. Would you rather get a book on Thursday or Friday? Friday?
Did you check on
I'm going to check it tomorrow. And I'll check the whole page. Alice, would you like your book today? You're really excited about getting your math book?
I don't mind.
You don't mind? Give it to me. I just want to look at it. It's a beautiful pre-calc book. Eris, what do you think? How are you solving it? Not really sure.
No, just for some house ones.
Not the best. Okay. You want to phone a friend? Oh, Nick. Yeah, Nick. What do you think, Nick?
For A?
Uh-huh.
Would you subtract the 1 from each?
Yeah, that sounds good. Take the 1 to the other side. So good first step, combining the numbers together. If you didn't want to deal with that fraction, what could we do so we didn't have to deal with the fraction?
Multiply both sides by 2.
Yeah, multiply both sides by 2. So let's get rid of that fraction. Multiply the left by 2. Make sure you're multiplying all of the right by 2 because it's x minus 5. So fraction is gone. We have negative 3x greater than or equal to, and then distribute 2 through, 2x minus 10. What else, Nick?
All the x's to one side.
Mm-hmm. Negative 5x greater than or equal to negative 10. And finally,
You divide by negative 5.
what happens when you divide by negative 5?
The sign flips.
Good job. And you get
X is less than or equal to 2.
nice job. Any questions? So it does say to graph on a number line, so come over here and graph a little number line. When you're making a number line, make sure you use equal increments, just like a graph. I don't know, start at negative 1, 0, 1, 2, 3, that's plenty. Doesn't need to be crazy. Sabrina, what do you remember about less than or equal to and how that kind of goes on the number line?
I think less than had an equal or equal to has a open circle.
What's the opposite of the open circle?
Closed circle.
Closed circle, yeah. So the equal to makes it closed because that number is part of the solution. And then which way are we shading?
To the left.
Yeah, to the left. There we go. So closed because it has equal to, shade to the left, it's less than. The second one is called a compound inequality. Compound usually means 2. So it's compound inequality because there are 2 inequality symbols in the problem. The expression is like squished in the middle. So we have this expression stuck in the middle of the two inequalities. Kate, what do you think you do with something?
I FOILed, so distributed.
Yeah, distributed the middle negative 3 through. So 1 minus 3x plus 6. And then what else could you do in the middle?
You add the 6 and
Yeah, combine those like terms. So we would end up with negative 3x plus 7. So parentheses are going, like terms are combined. How do you solve it? Alice?
Well, could you solve for like one side? So like set the negative 3x plus 7 is greater than or equal to negative 8.
So she said you can kind of isolate it and just pretend that you're solving for one side at a time. So one of the options you could do would be to take the negative 3x plus 7, make it greater than or equal to negative 8. Take the other side, negative 3x plus 7 less than 13. So literally you can separate them into its own two separate inequalities. What else could you do if you didn't want to separate them? Asia?
You can just subtract 7 out of both sides.
Right, you could also just take the minus 7 and apply it to both sides, because that's what you're really doing when you separate it. You're subtracting 7 from negative 8, you're subtracting 7 from 13. When it's separate, well, you can do that when it's together as well. But like it's the same exact thing, it just depends on what you see, how you feel comfortable solving the problem. So if we do it all together, we get negative 15 less than or equal to negative 3x less than 6. You're still going to have that same exact answer. Negative 3x is greater than or equal to negative 15. Negative 3x is less than 6. So Asia, if we keep with the left side here, if it's all together, what would you do next then?
Divide by negative 3.
And again, like everything gets divided by negative 3. So you would have what?
5 is greater than or equal to x, which is greater than negative 2.
Nice job flipping the signs. Don't forget, because you're dividing by a negative, to flip the signs. The last thing, when you see inequalities, especially a solution, if it's written in a book, if I give you an answer key, this is not wrong, but you're not going to see the answer written like this, because when we read numbers, when we read inequalities, it's always written from least to greatest, so you will see this flipped. You will always see the inequality signs opening towards the right, opening towards the bigger number. And again, the answer isn't wrong because you have it written the other way. It's just generally with math, we write things from least to greatest. So making this number line now, and then it correlates exactly with your number line. So going back to the negative 2, this time it says, looking in the middle, x is greater than negative 2, greater than is an open circle, and x is greater than it. So the negative 2 would then move to the right. Going back to the middle, it says x is less than or equal to 5, less than or equal to is solid, less than means move to the left. And you'll notice that they meet in the middle. Isn't that a song? It's my girl's favorite song. I don't know why. They listen to it all the time. Alexa, will you play the middle song by what's her name? She was just here with Taylor Swift. Right? No. I don't remember her name. That's somebody else. Who sings the song? Nobody knows. Where's the Alexa? Nobody has an Alexa at home? No, we got it when we got a new mattress, so that's the only reason we have Alexa. Good reason to buy a mattress, to buy an Alexa for free. All right, the last couple of things that we have today would be to talk about interval notation. Brandon, the homework is just to finish the solving equations page.
I think I might have already did, but it's probably wrong, so now I'll fix it.
Sounds good. And then maybe you want to just review interval notation, Brandon.
I will.
Okay, good. So underneath you have interval notation. I believe the notation should be written, but you might not have the inequality in the graph. So if you just want to like give yourself a little space, write inequality and graph, because we're going to have like what the inequality looks like, what the graph should look like. But interval notation is pretty much like the mature way of writing an inequality. We will not be writing inequalities from here on out through the rest of the year. It'll always be, your solution should be written in interval notation. And it'll say that for any kind of question we're dealing with, whether it's domain and range, or finding what part of the graph is greater than 0, whatever the question happens to be. So looking at the 9 different options, and there are only 9, these are the options for interval notation, there is a difference between 2 values having a bracket versus 2 values having a parenthesis. So thinking that they represent inequalities, so essentially we're taking our inequalities and changing them to this more mature way to write an inequality. What would a bracket mean with regards to an inequality, Chelsea?
Less than or greater than but equal to. Like, we can hit that number, can't
Say again?
we? Like, okay, if we had like 3,
Uh-huh.
it could be that number too.
Yes, it could be that number 2, right? Yes. So we'll say that the number is included in the solution. That's what you mean, right?
Yeah.
Okay. So it's allowed to be 3. If it says less than or equal to, greater than or equal to, that's what the bracket means. Equal to means bracket. So therefore, parenthesis means then the number is not included. That's just your less than, your greater than. So if you have less than or greater than, that's what parentheses represent. But the answer is not part of the solution. Even though it's there, it's going to go up to it, or it could start after it, but it's not going to be part of the solution. So the first interval says from A to B. A is always the smaller number. So just like I was saying with inequalities, you should start with the smaller number, go to the larger number. A will always be the smaller number. B should be the bigger number. You read from left to right. Numbers move from small to large. So A is always smaller than B. I'm going to start with what the graph will look like, and then maybe you can try and write an inequality. So we'll draw a little sketch over here. So this says bracket A to B with another bracket. We don't know what A and B are because they can be anything. We'll just write A and B down there as if they were numbers. So Chelsea said a bracket meant the number is included, which really means a closed circle. And the answer is somewhere between A to B. So we would shade in between, just like our last solution we just did. So the solution to letter B, you're shading in between 2 numbers. That inequality would be A is less than or equal to X, which is less than or equal to B. Because it starts at your first number, it moves through all the solutions and stops at the larger number. So that's what your inequality would look like. So if you have an inequality that looks like that, then we would write those numbers like bracket 5, 15, bracket. Smaller number to bigger number. The other 3 are just changing whether it's a bracket or a parenthesis. So the graph really isn't changing that much, it's just we either have open or closed circles. So parentheses mean just less than, so this would just say A is less than X, which is less than B. And you'll see that I will start converting to even putting parentheses on the number line instead of an open or closed circle. So instead of putting an open circle, you can just put the parentheses on the number line. Like I just, in my brain, will automatically do it. So if I do that, it just means that it really is an open circle. But parentheses, really open circle, you can put either one there. The parentheses then match exactly what your interval looks like. Both of those get parentheses, it's still in between. The other 2 is just make sure like you've got your less than or equal to next to the A, the less than with the B, or vice versa. So So if I'm just using brackets and parentheses, I would have a bracket and then a parenthesis for the third one down. And the fourth one would have a parenthesis with A and a bracket with B. If you choose to use open and closed circles, that's fine. If you still want to go back to the open and closed circle, that's fine. The next four only have one variable with them, which means one number, and there's an infinity with all of them. And notice every single one of the values that have infinity always gets a parenthesis. Because infinity, we don't know what the destination of infinity is. It's not a 5, it's not 7, it's not 1 million. We don't know what the number is. That's why it's always a parenthesis. You have to know what the number is in order to be able to include it in the answer. So looking at the graph again first of this one here, we have bracket A up to infinity. So bracket A up to infinity. That's what the graph would look like. So it starts at A, it goes forever to infinity. What would that inequality really be? Michael?
Just be A is less than or equal to X.
Yeah, A is less than or equal to X, or you could flip it around if you like to see the X on the other side. X is greater than or equal to A. Nice job, Michael. So it's bigger than A. And then the next one underneath, exactly the same thing. Either A is less than X or X is greater than A, but it's just a greater than sign instead of a greater than or equal to. So it starts at A, it moves on forever to infinity. And then the other two, negative infinity up to B. So now we're at negative infinity. We're going all the way up and stopping at B. B is the highest one. So it's going to be the opposite. You could say B would be greater than X, greater than or equal to, or X is less than or equal to B. And then the last one, we used a couple different ways to say negative infinity and positive infinity. Anybody remember that special notation? Eris, you remember? No? Chelsea? All real numbers. That was that fancy R, and our buddy Ethan, he always said, Mrs. Kane, can you just draw that again for me so I can see how you drew that? So the scripted R, all real numbers, every number exists. However you want to look at that. Questions? So tomorrow we'll start solving more interesting inequalities, writing them only in interval notation. So the answers will only be interval notation for homework for today. Finish the rest of that worksheet. So you should have at least the first 5 done. Finish those, please. And if you get a chance, you can start the next one. I wouldn't be checking that next one. I'm just checking that part 2 solving equations. Somebody like to do 9 or 11? Sabrina, that's right. I told you I'd get to you. Yeah. Sabrina's going to do 9. And Grace, you're going to do 11? Awesome. Yes.